video, we prove that the congruence modulo relation is an equivalence relation. So, first we have to know that what is an equivalence relation. So, suppose R is a relation. R is a relation on a non-empty set S. Then, if R is reflexive, symmetric, and transitive, then we say R is an equivalence relation. What is reflexive? Reflexive means for all A, B, C belongs to S, if every A related to A, that means every element is related to itself, then we say this is reflexive. R is reflexive. Secondly, for transsymmetry, if A related to B and A related to B implies B related to A, then we say the relation R is symmetric. And thirdly, if A related to B and B related to C implies A related to C, then we say R is transitive. So here in this video we prove that the congruence modulo relation is an equivalence relation. That means we prove that the congruence modulo relation is reflexive, symmetric, and transitive. Now first we define the congruence modulo relation. Suppose A, B are integers and M be a non-negative integer, non-zero integer. Non-zero positive integer. Then if M divides the difference of A and B, then we write A is congruent to B modulo M. This is the relation between A and B. Okay, M being a non-zero integer, and if the difference of A and B is divisible by M, then we write A is congruent to B modulo M. Now we prove this as an equivalence relation. Okay, so first we consider equivalency. We prove of equivalency. First, so consider A, B, C are integers and M a positive non-zero integer. So for reflexive, first we prove reflexive. Now we know that m divides 0. 0 is divisible by any integer. So this can be written as M also divides A difference A. A difference A, as A difference A is 0. So this we can write as A is congruent to A modulo, which proves that the relation congruence modulo relation is reflexive, as every A is related to A. This proves that congruence modulo relation is reflexive. Now secondly, you prove symmetry. Suppose A is congruent to B modulo M. This implies that M divides the difference this can also be written as M divides the difference negative of B difference A, which is the same thing, which implies that when M divides the negative of B minus A, this implies that M divides the positive part of B minus A also, which implies B is congruent to A modulo M. So here what happened? A is congruent to B modulo M, that means A related to B implies that B related to A. Hence our relation is symmetric. And thirdly, we prove transitive. Suppose A is congruent to B modulo M and B is congruent to C modulo M. Then this implies that M divides A difference B, and this implies M divides the difference B difference C. Now the property of division, we can also write that M divides the sum of these two numbers, as M is a multiple of these and a multiple of these. M is a factor of these and also a factor of these. So M is also a factor of addition of these two numbers, A minus B plus B minus C. For example, suppose we know that 3 divides 15, 3 divides 9, and 3 divides 6. 3 also divides 6, you know that. This implies we can write that 3 divides 9 plus 6, that is 15. 3 divides 15. Now, so here also like that we can write that. Okay, M divides A difference B and M divides B difference C. This implies that M divides the sum of this. This implies that here the minus B and plus B are cancelled. What do you have? A difference. This implies that A is congruent to C modulo M. Hence this proves the transitivity. Hence the congruence modulo relation is a reflexive, symmetric, and also transitive. Hence the congruence modulo relation, hence the congruence modulo relation is an equivalence relation. Thank you.